Here's a question. You've got two numbers to add, but each one is split apart into single digits. How would you do it? Say the first number is 342, and the second is 465. We want their sum, 807. Each digit lives in its own node, and each node points to the next, like a treasure hunt where every clue leads to the next clue. But there's a twist. The digits are stored backwards. The first node is the ones digit, then tens, then hundreds. And we hand back the answer the same way. The sum 807 comes out as a list of 7, then 0, then 8. Try the obvious thing first. Walk list 1 and read all its digits into one real number. Do the same for list 2. Now you've got 342 and 465. Add them the normal way and you get 807. Then chop that number back into single digits and rebuild the answer list. It works, and it gives the right result. But look at what you just did. You turned two lists into two whole numbers, only to take them apart into digits again. And these lists can run 100 nodes long. In a language like Java or Go, a 100-digit number is far too big for a normal integer, and it overflows. Now think about how you'd add by hand. You don't glue the digits into one number first. You go column by column. So what if we do exactly that here? Take the two matching digits, add just those, write down one result, and move on. That's the move, column by column addition. And since the digits are already reversed, the ones column comes first. That lines up perfectly. One catch, 4 plus 6 is 10. 10 doesn't fit in a single-digit slot, so we keep the last digit and carry the one forward. That carry is the only memory we need. It's just one small number, handed from each column to the next one. Watch out for one mistake. You might think to stop once both lists run out, but if the last column carried a 1, you still owe one more digit. Let's run it. Carry starts at 0. We also keep a fake starting node, so attaching the very first digit needs no special handling. First column. 2 plus 5 is 7 plus a carry of 0. Nothing spills over, so we attach a node holding 7. Next column. 4 plus 6 is 10. 10 won't fit in one digit slot, so something has to give. We keep the last digit, which is 0, and attach a node holding 0. The leftover one becomes the carry into the next column. Last column. 3 plus 4 is 7 plus the carried one, that makes 8. We attach a node holding 8. Both lists are empty now, and the carry is 0. There's nothing left to add, so we stop. Drop the fake node, and the answer starts at 7. Read it out as a whole, 807. Correct. Notice what we never did. We never built those big numbers. Each digit got touched once, and the carry held the only memory we needed. We walk each list one time, so the time grows with the longer list. The answer holds one node per digit, so the memory grows the same way. Same logic, now in Python. We make a fake starting node, a pointer to build from, and set the carry to 0. The loop keeps running while either list still has a digit, or there's a leftover carry. That last part catches the final one. Inside, we read each digit. If a list has already run out, we treat its digit as 0, so two different lengths just work. We add the two digits and the carry. The new carry is whatever spilled past 10, and the new node takes the last digit. Then we step all the pointers forward. When the loop ends, we hand back the list that starts right after the fake node.